Alrighty, we are back with another state test prep video. Today we're talking about standard S.ID.3. Let's jump right in. Question 1. The histograms shown display the number of cans of food donated by students in the freshman class and the sophomore class at a school. Which statement is true? The freshman class has a lesser mean number of cans donated than the sophomore class. The freshman class has the same median number of cans donated as the sophomore class. This freshman class has a greater mean number of cans donated than the sophomore class, or the freshman class has a greater median number of cans donated than the sophomore class. So when you're looking at a histogram, it's very difficult to identify mean and median because you're not shown exact numbers, you're shown number ranges. Okay, so let's figure out what we can extrapolate off of this. All right, so we have 22 people, 44 people, 44, 69, that would be 96, 110, 132, 154 students here. So you have 154 students here. Okay, I got that by adding up, 22, 22, 25, etc. And here we have 21 plus 22 is 43, plus 23 is 66, plus 26 is 92, plus 26 again is 118, plus 22 is 140, plus 21, 161, plus 21, 182. I'm very worried that I have errored somewhere here. Let me double check. 22, 44, 69. Six, 110, 132, 153. But it's hard to tell a mean. It would be easier to tell the median because the median would be about halfway through, which in this case would be the 76th or 77th person. The 76th person would fall in the range of 70 to 75 because this range has 22, 44, 69, and this range covers that 77th person. Meanwhile, 182, which again, I'm going to double check my math real fast. 66, 92, 118, 140, 146, 161. Yeah, 182. So 182, your median would fall in the 91st person. So 21, 43, 66, 92. So your median would fall between 75 and 80. Okay. Does the freshman have the same median? No. Does the freshman have a greater median? Also no. Okay. So now we talk about mean. Okay. Mean is a little bit easier to tell because it's an average, right? It's hard to come down to an exact mean, but what you can look at is the graph itself. Okay, you see in the freshman class, a lot of our people are skewed more to the left side. There's people at the minimum numbers and no one at the maximum numbers, right? And the bulk of our people are 70 to 75 and 65 to 70. Meanwhile, if you look at the sophomore class, they have no one at the minimum. They have no one at 55 to 60 and have 21 people each at 90 to 95 and 95 to 100. This suggests to me that we can make the reasonable assumption that the freshman class has a lower mean than the sophomore class. And that's what it comes down to ultimately. So did we need to calculate the median? No. We could have figured it out based off the mean, based off the graphs. However, I wanted to show you the process of finding the median, just so you would know it in case that comes up at some point. All right. Question 2. A group of students measures the distance a toy car has traveled after different amounts of time. A table of the data is shown. The students want to perform an analysis of the data set and consider removing the outlier point. Select all of the quantities that will change if the outlier point is removed from the data set. When you talk about an outlier, okay, if you don't know what an outlier is, it's kind of like the one that doesn't belong. You can sometimes hear the word outlier used in like a social context of people who just don't seem to fit in with any other friend group. But here it's used in the case of statistics that don't make sense. So for example, we have time 5 seconds. 1 goes 1 meter. 6 seconds goes 1.2. 7 goes 2.4. 8 goes 3.3. 9 goes 3.7. This all makes sense. It's steadily going up. Then 10 all of a sudden jumps to 11, and then 11 is 4.2. Something weird happened here. I don't, we don't know what, but something weird happened here. So if you were to take out this data point, what would change? Okay? So first we talk about the mean of the time. The mean of the time would actually, hilariously, not change. Let's put this information into Desmos. That's what we should be doing at first. I gotta clear out my stuff from the last video. Here we go. We're gonna put it into a table. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then 1.0, 1.2, 2.4, 3.3, 3.7, 11.0, 4.2, 3.7, 4.8, 4.5, 4.9. 12, the 12 3.7, I just want to make a note, is not necessarily an outlier because while it seems to have been going up steadily and it randomly goes down here, it's not a huge drop. We call it, it's not really statistically significant of a drop. This is hilariously out of place. As you can tell, it's far above everything else. This at least stays in line with everything else. All right, so let's put in our stats. Oh my goodness, I cannot type the word stats. Stats of x1. Okay, so for this, we need to know the mean, the median, and the range. So as of right now, x1 has a median of 10, a range of 15 minus 5, which is 10, and a mean, well, it doesn't tell you the mean here, but you can go to a new line, mean, x1, and a mean of 10. Okay? Then we go to our y1, because we need to know the means and stuff of the distance. So we're going to change this to y1. This has a median of 3.7, a range of 11 minus 1, which is 10, and a mean of 4.06. Okay, so I've now written down all of that data. So what I'm going to do now is I'm going to take out the line of 10 and 11.0. So we'll take that out, and we'll take that out, and we'll see what changes. Y1, since it's already in here. The median is still 3.7. The range is now 4.9 minus 1, which is 3.9. And the mean is now 3.37. The mean went down, which is to be expected because we took out the highest number by far. So the mean went down critically. The median didn't go down. There's a variety of reasons that it might not have gone down, but it could be expected for that. The range going down is also expected because, again, we took out the highest number. Now let's see what happens to x1. X1, your median, remains 10. Your range is 15 minus 5, which is 10. And your mean is still 10. So none of our median, range, mean, none of that changed because we took the thing in the exact middle. And the mean would have changed if the mean was not already 10 to begin with. So that's fine. So what changed? Mean of the time, that's our X1 column, stayed the same. Mean of the distance, definitely changed. Median of the time, did not change. Median of the distance, did not change. Range of the time, did not change. Range of the distance, absolutely changed. And remember, I'm going to say it every time we see it, select all, more than one right answer. Okay, move to question 3. A gardening club measures the weight in pounds of each pumpkin in its garden at the end of the growing season. The histogram shows the weights of the pumpkins. It says complete the statements that describe what happens to the mean and the range of the data when all the pumpkins in the 4 to 6 pound category are removed. Okay, so what this is saying is that if you take out this, of which there are 2 pumpkins of this, what's going to change? Well, the average weight, okay, will very much increase. Why? Because you got rid of the lowest weighing pumpkins. So naturally, your mean will go up. If you're removing stuff that is below the mean, your mean will go up. If you're moving stuff from above the mean will go down. This is very much below the mean, so the mean will go up. The range of the data will decrease. The reason the range of the data is because this is, let's say that these pumpkins represent a 4 and 5 pound pumpkin, and let's say that this pumpkin is 21 pounds. If you did 21 minus 4, your range would be 17, but by getting rid of the 4, your new lowest pumpkin is probably 10. 21 minus 10 is only 11, so your range 100% decreases. All right. Question 4. 2 friends record the number of minutes they spend on their cell phone every day for 1 month. They display their results in the box plots shown. Complete the statements to make conclusions about the data represented by the box plots. Okay, I'm going to have to zoom out just a smidge here. It's not doing what I want to do. All right, there we go. Okay. So, the friend that most likely has an outlier in his data is friend blank, and the outlier is likely the blank value. Therefore, for this friend's data set, the mean is most likely blank the median. Okay, so let's look at this. Remember when we talked about box and whisker plots? We talked about it representing what was called the 5-number summary. Okay, so I'm going to redraw this. I know my hand's blocking the camera for a second. This represented your minimum value. Oh, too high. This represented your minimum value. This represented your quartile 1, which was essentially the median of the lower half. This represented your median. This represented your quartile 3. This represented your maximum. Okay? Now, quartile 3 is your median of the upper data. So just by looking at this, without even knowing what this represents, without even knowing what a quartile 3 is, which friend do you think has the very obvious outlier? It's friend 1. The very obvious outlier is the maximum. The maximum is way, way out here in flippin' Space Guam. Way far away from Q3. Because remember, Q3 represents 3/4 of your data. Okay? That represents what number is 3/4 of the way through the data. So, from your first quarter to your second quarter is 5 to about 17.5. And then from your second quarter to your third quarter is 17.5 to 25, which is a difference of 7.5. And then all of a sudden, from the third quarter to the fourth quarter is 30. That's just wild. Therefore, for this friend's data set, the mean is likely higher, greater than the median. Why? Because when you have one number that throws off that data that much, it's going to inflate the mean. Okay? Even just look at the difference of if you have 1 plus 2 plus 3 plus 4 plus 5. Okay? The mean of that would be 3. You would add all those up. 1 plus 2 plus 3 plus 4 plus 5 is 15. Divide that by how many numbers you have, which is 5. 15 divided by 5 is 3. Now let's pretend you throw another one on here. 1 plus 2 plus 3 plus 4 plus 5 plus, I don't know, 21. So now, 1 plus 2 plus 3 plus 4 plus 5 we know is 15, plus 21 is 36. Divide that by how many values there are, of which there are 6. Your mean now becomes 6. Your mean doubled. Because one outlier throws off your data that much. Here, your median is 3. Here, your median is 3.5. Your mean is so much higher than your median. Excuse me. All right, let's move to question 5. A restaurant surveyed its customers by asking them to rate their dining experience on a scale of 1 to 10. The results for all 200 participants are shown in the histogram and the table. Which statement justifies why the median is greater than the mean? Is it A, the data is skewed? B, there is a large standard deviation? C, there are gaps in the data distribution? Or D, the distribution is roughly symmetrical? These are not even close to symmetrical. Symmetrical means that if you, have like this, 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 this is symmetrical, where if you split it down the middle, it would almost look like you're looking into a mirror, where it reflects each other. This is nowhere close to that. Okay? There were gaps in the data distribution. Does not explain why the mean is larger than the median. The reason the median is greater than the mean, which statement justifies why the median is greater than the mean? Yeah, is because the data is skewed. The data is skewed hilariously. So there's 200 people, right? So your median would be around the 100th person. It would actually be easier to start at the end. There's 30 people here, and there's 70 people here. 30 plus 70 is 100. So that means that your median would be right here, right at the very edge of this bar. Way at the side. Way at the side. That's throwing it off terribly. While your other 100 is a lot of lower numbers far away from the median, so that throws down the mean. All right, so that's going to do it for this standard. If you have any questions, please feel free to let me know. Otherwise, I will see you in class, and good luck on your state test.